Hey everyone, we should have finished chapter 3 in the previous week. This is the beginning of chapter 6, more specifically 6.1 on systems of equations. So in the do now, they want you to graph the equation y equals 3x minus 2. Well, this is a skill that we've learned a few months ago, okay? Remember, our equations are in y equals mx plus b form, where your m is slope and the b is your y-intercept. So these are the same skills that we used when we were graphing our inequalities last week. If you take a look, what they give us, m is 3, but we like slope as a fraction, so 3 over 1, and our b value is negative 2. The negative 2 is where we're going to start. So that's your y-intercept, where we cross the y-axis. So I'm going to go down 2 from the middle. I know this graph doesn't have numbers, okay, but each line represents 1. So there's negative 2 from the origin. My slope, 3 over 1, tells me to go to the up 3 and to the right 1. So I'm going to follow that pattern and put a point. I'm going to keep going until we run out of room. Now we're off the page. Now, if you can't continue up and to the right, you're supposed to do the opposite and go down and to the left. So we should have a total of 4 points for this line. I'm going to connect. I'm going to put arrows on the end. And a skill that I taught you when we were graphing equations the first time, we need to label. Y equals 3x minus 2. Take your time, feel free to pause. I know I can go kind of quick when it comes to graphing. And resume the video when you're ready. Vocabulary terms. System of equations. A system of equations means two or more equations with the same variables. We're going to be working with systems. It might be 2 equations, it might be 3 equations, which means we're going to have to plot either 2 or 3 lines on a graph. Now there's 3 different types of systems of equations. The first type is called consistent dependent. Consistent dependent systems are a system of equations that have an infinite number of solutions. Infinite. Now, these are going to look very distinct, and you're going to be able to just look at a graph and tell if it's consistent dependent. And you can tell because the lines completely overlap. And I'm going to put a little note here. It looks like only one line. So if we're dealing with systems of equations and we look at the graph and I only see one line, that means consistent dependent. Now, the second type is consistent independent. Okay, consistent independent is a system of equations that have exactly one solution. A system of equations that has one solution, what that means is the lines cross exactly one time. And you're going to be able to identify those right away because it looks like some sort of X. The solution being the point where they cross. We're going to look at more examples of these, so don't get overwhelmed if you're a little unsure at the moment. Then the last type of system is an inconsistent system. Inconsistent. Inconsistent is a system of equations that does not have a solution. The lines never cross. never cross. Okay, and we've learned in the past that lines that never cross are what type of lines? Lines that never cross are called parallel lines. Parallel lines have the same slope, and they'll never cross each other. So again, feel free to pause to fill in your definitions and write down the extra notes, and you can resume the video when you're ready. Vocabulary terms. It says label the three graphs: consistent dependent, inconsistent, consistent independent. Well, let's go back. The last one we just learned was inconsistent. The key there was that they never cross. While looking at my three pictures, over on the right hand side I see parallel. Over here, those two lines, the blue and the orange, are never going to cross. That's inconsistent. Okay, now I was trying to remember between the two, consistent dependent and consistent independent. Consistent dependent. The lines completely overlap, and remember my note, it looks like only one line. So if I go back, which one only looks like one line? And that's the one right in the middle here. So consistent dependent. Now I only see a blue line. Where did the orange line go? The orange line is actually underneath the blue one. They're totally overlapping each other. So there's two lines here that appear as one, which means every point on the line is a solution. That's why they call it infinite solutions, because every point is a solution. The last one is consistent independent. Consistent independent is a system that has one solution. The lines cross exactly one time. Okay, so we know now our consistent independent solution is over here. Exactly one solution. Like we said, it makes that X shape, and the solution is where they cross. Solving a system of equations by graphing. So we're going to graph and find the solution of our first system. Okay, we have two equations. They're both written in slope-intercept form. So we know we have an M and a B. And then I'm going to do my second graph in red, and we have an M and a B. So let's start with the blue one. The M value is 2, but it's really 2 over 1. And the B value, or the y-intercept, is a positive 4. So I'm going to start up 4 from the center. Up 4 from the origin. Now my slope says to go up 2 and over 1, but that's off the graph. So instead of going up and to the right, you need to do the opposite, which is down 2 and to the left 1. Okay. Gonna connect these. Let me see if I could change this to blue. There we go. A little off center there. Let's redo that. There we go. Okay, put arrows on the end and label. Y equals 2x plus 4. Now we have to do the same thing for the red equation. our slope. Now there's a number in front of that x that we don't see, and it's 1. So my slope is 1 over 1. Our b value, our y-intercept, is positive 2. So I'm starting up 2 from the origin. I'm going to follow that up 1, right 1 pattern. We're going to continue that trend all the way through the graph. We are going to connect with a line. I'm going to label the red equation y equals x plus 2. And now the most important thing is finding where the red and the blue lines meet. And they meet right here. And that location is our solution. And that solution is located at the point -2, 0. Okay. So, if I were to ask what type of system is this, well, they create an X-like shape and there is one solution. Consistent, independent system. So I'm just going to write that on the bottom. Consistent, independent system. Okay. Here's another example. Now we have a green and a purple line. But again, it's the same process. We find the slope and we find the y-intercept. Our slope is 4 over 1. Our y-intercept is positive 3. So I'm going to start up 3 from the middle. My slope says to go up 4 and to the right 1. But again, we run out of room. So we need to go down 4 and to the left 1. And we should be able to plot 3 points. Okay. Here's our line. And I'm going to save the labeling for the end, just to keep things a little neater. All right, now we have a purple line, our M. Now this time it's a -1 over 1. And our B value is -2. So I'm going to start down 2 from the center. Now, -1 on top means down, and a +1 underneath means right. So down 1, right 1. And when you can't go down and to the right anymore, you need to go up and to the left. Connect our points, put our arrows on the end, and now I can label. So I'm going to label y equals -x minus 2, and our green equation was y equals 4x plus 3. Now our solution, again, is where they cross. So the solution is at the location -1, -1. Again, it makes an X-like figure, so that is consistent, independent. Writing a system of equations. One satellite radio service charges $10 per month, plus an activation fee of $20. A second service charges $11 per month plus an activation fee of $15. In what month was the cost of the service the same? So the first thing they want us to write is two equations representing the yellow highlighted information and the blue highlighted information. Okay. C is going to represent, and I'll do this in black, the total cost. N is going to be the number of months. So our first service, service 1, is the yellow highlighted information. C is equal to $10 per month, so 10 times N, plus this $20 activation fee. Service 2 is the blue information. Again, the cost is going to equal, but this time it's not $10 per month. In the blue information, it says 11, plus an activation fee of $15. Which variable will we use, will we graph on the horizontal axis? So, horizontal is X, vertical is Y. If you take a look at our equation, usually we write our equations as Y equals. But with both of these services, the equations we just wrote in those colored boxes say C equals. So the C is our Y value on the vertical axis, which means N is the variable on the horizontal axis. What will the intersection of the graphs of the two linear equations tell you? So when we plot these lines are going to make an X value at some point. They're going to cross, and there's going to be a solution in the middle. That solution is going to be when the cost of the services are the same. Okay, so we're going to graph these two on the next page. Graph the equations we wrote in exercise 14 on the grid on the right. Which ordered pair gives us the point of intersection of the two lines? So, if we notice, the total cost is going up by $10, right? 10, 20, 30, 40, 50, and so on. The x-axis, or the number of months, is going up by 1 each time. 1 month, 2 month, 3 month, 4 month, etc. So let me bring the two equations over. C equals 10n plus 20. And our second equation is C equals 11n plus 15. Okay. Let me see, I'm going to make these two distinct colors so we can tell the difference, if I can. Maybe not. Okay, so we'll just classify. I'm going to do the first color in red, and I'll do the second one in, let's do green. So the first one, my M is 10 and my B is 20. So from the origin, which is the corner in the bottom left of this graph right here, the origin, I'm going to go up 20 and put a point. So there's our first point. My slope tells me to go up 10 over 1. So go up to 30 and go over 1. Up to 40 over 1, up to 50 over 1. And follow this pattern all the way through. Okay, now we can connect these points. And here is the graph and the cost for service 1. Now we have to switch and do service 2. Service 2, says to start at a b value of 15, and the slope is 11 over 1, which could be a little tricky. So 15 falls in between 10 and 20. Okay. Now to go up 11 would mean that it would be 26 over 1, so a little over the halfway mark. Then 27 over 1. 37, excuse me. Then 48. Then 59. And then 70. So these hit at the same point at 5, 70. And we'll keep going. 81. 92. 103. And then we're off the graph. So I know that could be a little tricky given the margins. I'm going to try and make this one thinner if I can. I don't think so. All right. So here's our graph. And again, our 2 points meet right here. And that point is 5, 70. So after 5 months, the cost of the services is the same, and that cost is $70. It's a tough one. Exit slip. Solve the system by graphing. Again, we have 2 equations. This should say y equals. I'm not sure why that's cut off. Y equals and y equals. Is that? Oh, there we go. Much better. Okay. So again, we could plot these in 2 different colors so we could see. I'm going to do the first one in red. And why not? We'll do this cool pink color. Boom. All right, solve the system by graphing. The slope of y equals 1/2 x plus 6 is 1/2. That's our m value. The y-intercept is a positive 6. So let's start there. We're going to go up 6 and put a point. Now I'm supposed to go up 1 over 2. So again, we're dealing with half margins, which is a little tricky. Go in between where our red dot in the 8 is and go over and put a point. Go up to 8 and go over to 4 and put a point. Follow that pattern. Middle corner, middle corner, middle corner. And follow it all the way through. Middle corner, middle corner. Okay. And we can connect these points. Okay, change colors. The slope of x minus 2, and excuse me, my dog, if you can hear him, he's barking at squirrels through the front door. The slope of y equals x minus 2 is 1, or 1 over 1, and the y-intercept is negative 2. So go down 2 from the middle and put a point. Now I'm supposed to go up 1 and to the right 1 every time. Whoops. And there we go. Error on the first one. Here we go. This is going to be a little tricky. Go halfway up and over. So middle of a box, corner of a box, middle of a box, corner of a box. And follow that pattern all the way through. And we can already see where they intersected. All right. So the intersection point that we can see is actually right here. And that's at the point 16 And right here, what's in between 12 and 16 would be 14. So 16, 14. Just connect your purple line, and we'll label. Y equals x minus 2. Y equals 1/2 x plus 6. And our solution is 16, 14. So again, one solution. These lines create that X shape. They overlap one time. That is consistent, independent. Okay? Feel free to reach out to me via email or the Google Voice.